do today is we're going to focus on calculations involving heat energy. So my videos aren't going to be talking about the concepts as such, they're just going to be focusing on solving some problems, some example questions that you'll typically get at A-level and GCSE. This video is going to be focusing on GCSE. So there's some information that can be read about heating, cooling down, and about change of state. And there's a formula that we're going to use. Heat change equals mass multiplied by specific heat capacity multiplied by temperature raise. Delta Q being the heat change, M being the mass, C being specific heat capacity, and delta theta being temperature rise. There's a second equation that can be used when I'm talking about change of state. That's delta Q equals mL, where delta Q is the heat change for mass, M is the mass, and L is the specific latent heat. This can be used either for specific latent heat of fusion of ice or latent heat of vaporization of water, which are the two examples are given here. So if we have number one, question one, here's some nice easy ones to get started with. 1A, find the heat given out when 50 grams of iron cool from 45 to 15 degrees C. If we go to the way this is done, we see that delta Q equals mc delta T. So we always start with a formula, then we substitute in the given numbers, 460 for the mass, 0.05 for specific heat capacity, and change of temperature is 30 degrees. So this gives our answer 690 joules. It's an energy, so the unit has to be joules. 1B, find C, that is the specific heat capacity for gold, if 108,000 joules, that is 108 kilojoules, are needed to raise the temperature of 9 kilograms from 0 centigrade to 100 centigrade. So we write C, specific heat capacity, equals delta Q divided by M delta theta, so we've rearranged the equation there. And this is equal to 108,000 divided by 9 multiplied by 100 in brackets. So we do that 9 by 100 first. And then we divide it through the 108,000 and we get 120 joules per kilogram per Kelvin. Make sure you can do that on your calculator and you know which order to put it into your calculator so you arrive at the value of 120. There's no unit conversion required because we've got joules, kilograms and Kelvin, which are all SI units. We have these per kilogram per Kelvin because these numbers are on the bottom of the division sign. Question 2. A lump of lead, mass 0.5 kilograms, falls from a height of 25 meters. Part A, calculate its kinetic energy just before reaching the ground. 2A, so the energy, gravitational potential energy, I put as a subscript GPE, equals the kinetic energy, so subscript K here. Now this is conservation of energy. If you're not sure about the concept of conservation of energy, see one of my other videos. So kinetic energy is equal to this, gravitational potential energy, and gravitational potential energy formula is mgh. So in this state, the kinetic energy, even though that has a different formula, we can use this one because it's equal, it's the same as the gravitational potential in this case, gravitational potential energy. So we substitute 0.5 mass, G 9.8 I've used here. Some syllabuses require 9.81, you need to check on that. multiplied by 25, gives you 122.5 joules. Now, in terms of significant figures, this could be then given to just one significant figure because the mass is only given to one significant figure in the question. So really, an answer of 100 joules would be acceptable. But it's very good you need to show the working, and